morning. Welcome to first year students who have joined one of the prestigious institutions in Karnataka, the National Institute of Engineering. Myself, Dr. T.N. Shridhar, Professor from Department of Mechanical Engineering. And this particular course, which is considered as Computer Aided Engineering Drawing, so in short we call it as CAED. And even though we say, or the teaching department is Department of Mechanical Engineering, strictly speaking, this subject can be taught by any engineer, because you should know that drawing can be considered as it is a language of engineers. So engineers should have an idea of visualizing things. So that is the reason this particular course plays a very important role in your entire career. But generally there is a perception saying that this computer aided engineering drawing, or in particular engineering drawing, will be taught or will be required only for mechanical engineers, civil engineers, as well as industrial production. Let me say that for non-circuit branches. So generally the circuit branches, that is computer science, information science, E&C and E&E, they feel that it will not be required. But as I was just mentioned, this particular course is the fundamental course for any engineer. Before going for engineering drawing, so just I wanted to know from the students, I think already you would have exposed to drawing in different contexts, starting from your primary level itself. And as soon as you come to your high school level, you would have seen the geometry. So there also you have done a lot of drawings, and especially once you come to PU level also, I think this drawing is mandatory for any of the courses you would have studied. Now as far as this engineering drawing is concerned, the foremost word what generally we use is known as projection. Okay, now I want from you what exactly you mean by projection. So I think you would have heard this particular term in different contexts. Okay, so what exactly we say that if I say projection, generally for a common man, they may say that projection is, for example, something we have given importance to it. For example, we say that a particular, I can say, leader has been projected. That will say that we are giving prominence to a particular aspect or to a particular person. Now as far as this particular drawing is concerned, and again I need to emphasize the importance of engineering drawing, because any engineer is required to design any product. So that product may be a core engineering product, or it can be an electronic product, etc., etc. So wherever we wanted to design a product, so actually the sequence is like this. So first of all, we need to visualize how that product has to be. Somebody say that we may have to conceptualize that particular product. Then I need to put that in let us say in a paper. Then finally we are going to, let us say, freeze that particular concept. Then once I freeze that concept, then I need to give the dimensions to that particular product. So once I give the dimensions to the product, and always remember, a product is always a three-dimensional figure. That is, it is having all the three dimensions, that is length, breadth, as well as I can say thickness. Now since we have these three dimensions and I need to visualize, generally whenever I want to visualize any product, we need to put it on a paper. Okay, so let us say if I put it on a paper, so paper is a two-dimensional figure. Somebody say that I cannot show all the three dimensions on the two-dimensional paper. That is the reason we may have to view the object in a particular direction so that I can get the details of the entire product. Now, as you can see, I told you that this paper is a two-dimensional figure. That is, I can show only length and breadth. Let us say if I want to show the thickness of that particular paper, that particular product, I may have to view from the other direction. Is it okay? That is the reason wherever we wanted to put a three-dimensional object on a drawing sheet or simply a paper, we need to project on it. So if I say projection, so what is the projection? Generally what we do is, let us say we have an object. Then what we do is, we just look the object from, let us say, from the front. Then let us say I am going to draw the lines from the entire contour of the particular object to a plane. Because always a plane in this particular case, I can say a paper or a drawing sheet. So once I put all the salient points of this particular contour on this particular paper, then if I join all the points in a proper sequence, then I can say that this particular this particular product has been, or object has been projected onto this particular paper. So that is the reason we consider that as a projection of that particular object. Now, again in this particular case, I told you that we have drawn the lines now. So those lines which are drawn from the salient features of that particular contour of the object to the plane, so those lines are known as projectors. Then the projectors which are going to intersect this particular plane, we are going to get a point. Then as I told you, if I join them in a proper sequence, I can now say that this particular product has been projected. Now, generally in engineering drawing, we are interested in what is known as orthographic projection. Orthographic projection. Okay, now tell me, already told you that we have understood what is a projection. That is, an object has been projected on a particular plane. Then we say that the object has been projected. Now, what do you mean by this orthographic projection? So as the name indicates, we have this ortho. So what is this ortho? That is perpendicularity. So what is the perpendicularity we are talking about? Anyway, I told you that we are having these lines. That is, the lines which has been drawn from the contour of the object to the plane. So all these lines which has been drawn from different points or different contours, different points of the contour, then if those lines are parallel to one another, not only that, if those lines are perpendicular to the plane on which I am projecting, then we consider that as orthographic projection. That we say that the lines which has been originated from the object to the plane has to be perpendicular to the plane. Wherever that particular lines are perpendicular to the planes, we consider that orthographic projection. Then the lines which are joining from the object to the plane, that particular lines are known as projectors. So I can say that when the projectors are perpendicular to the set planes, then we consider them as orthographic projection. Not only that, all those lines will be parallel to one another. As I was telling you, generally in projections, we are always, it is universally, they will follow what is known as orthographic projection. And as I was telling you just now, in orthographic projections, the lines which are originating from the object to the planes, all those lines are parallel to one another. Not only that, those lines will be perpendicular to the set planes. And since those lines which I consider them as projectors. So what is a projector? A projector is a line which joins from the object to the plane. Okay, that particular line can be considered as projectors, and in orthographic projection, all these projectors are parallel to one another. Not only that, those projectors are perpendicular to the planes. Okay, now anyway I told you that in the case of projection, we need to project the object to a particular plane. Now let us consider a simple example which I am going to illustrate in this particular sketch. Okay. Now let us consider we have this rectangular block. Okay. Let us consider the rectangular block, and I am interested to project this particular rectangular block onto the planes. Okay. Now to consider the planes, generally first I need to know where exactly the observer is standing. Okay. Now let us say that in this particular case the observer is standing in the front. Okay. Now the observer is standing in the front, and corresponding to this observer, this is the object, that's what I am showing. This is the front position, front, then we have this object, then I am going to project this object onto this particular plane. Now with reference to the observer, how this particular plane looks to be, this plane looks to be vertical to me, that is vertical to the where I am standing. That's the reason we consider this particular plane on which we are projecting as a vertical plane. So let me consider this as VP. So VP means a vertical plane. Okay. Now as I was telling you, since it is a three-dimensional object, I can get only two dimensions on this vertical plane. So I need to consider another plane. So that another plane can be considered as a plane which is perpendicular to this vertical plane. Now since it is perpendicular to this vertical plane, we can consider that plane as horizontal plane. So I will consider this as HP. So I can say that to consider the projection of this particular object, we employ two reference planes in this particular case. So we consider these planes as principal planes of projection. So these principal planes of projections are considered as vertical plane, that is vertical with reference to the observer, and the other plane which is perpendicular to this particular vertical plane can be considered as the horizontal plane. Okay, now let us say I am looking from the front, then I need to project this object onto this vertical plane if I stand in the front. Okay, now for clarity, let me consider the dimensions for this. Let us say I will consider this dimension as some x. Okay, so x is one dimension. Then let me consider this dimension as y, or let me not call it as x, let us say p. Let us say p, let me call it as q. Then the other dimension, so as you can see, for the observer, I can say this is the width of the object, I can say this is the height of the object, then I can have this third dimension. So the third dimension, I can say thickness. So let me consider this thickness as some s. Okay, so I am just considering p, q and s are the dimensions of this particular object. Okay, now if I look from the front, so as I was telling you, in orthographic projection, we need to draw these projectors. The projector should originate from the object, then it has to be drawn vertical, perpendicular to this plane. Wherever it intersects, I am going to get a point. So I am going to get a point here. Okay, so with this, I am just seeing from the front, I can see this here. So I just projected this point. Similarly, let us say I want to project this point B. That is, again I have drawn this projector and it will intersect this particular plane at this particular point. But in this particular case, interestingly, you can see E and F. They are exactly behind this AB. That's the reason if I draw this projector, both A and E will be on the same projector. Similarly, B and F will also on the same projector. Similarly, let us say I want to project this D. I am going to project D here. I am going to project this C here. Okay. Now, once you project this point, I told you that I need to join them in a proper sequence. Okay. Now, let us say if I look from the front, I can see only this rectangular plane. I can see only A, B, C, D. I cannot see this E, F, G, H because E, F, G, H are exactly behind A, B, C, D. So, if I look from the front, I can see A, but I cannot see E. Similarly, I can see B, but I cannot see F. Similarly, I can see, but I cannot see G, N. I can see D, but I cannot see H because these 4 points are exactly behind these 4 frontal points. Okay, now since I am looking from the front, and projecting onto this particular plane. That particular plane, I told you just now, it is a vertical plane. Since it is a vertical plane, I am looking from the front. I can consider that whatever we project on the vertical plane as front view. Now, I told you that we need to sequence it. I need to name them. So, I can say A. So, I will put A here. And it is convention that always, wherever we show these points on the views, if it is a front view, always we consider them as A prime or A dash, B dash, C dash, etc. Okay, so let it is A dash, then this point is B dash, then this point is C dash, then this point is D dash. Okay, now tell me, I can see only A, B, C, D. Can you see this E, F, G, H? I cannot see because E is exactly behind A. Since I cannot see this particular point, I need to show this point E here also. But since I cannot see this, I will put this in brackets. So it is E dash. Similarly here, behind B, we have this F. So I said F dash. And similarly, behind C, we have this G or G dash. And behind this D, we have this H dash. So as you can see, whenever the convention is in the front view, we are going to show these points as small letters. See this, I have written all capital letters here. So capital letters actually indicates the actual points on the object, whereas small ABCDs etc. will be on the views. Now since it is the front view, remember I always should show this as A dash, B dash, C dash, D dash, etc. Is it clear? Now, as you can see in this front view, I can see only two dimensions. What is this dimension I can see? What is this dimension? This dimension is P. So I can see only P I can see. And what else I can see? I can see this height. That is, what is height I shown? I shown this height as Q. What about yes? Can I show this yes now? Because if I look from the front, anyway this point H will come behind D. We cannot visualize this yes. That is, I cannot see from the front. See, if I see from the front, I cannot make out what is the thickness of this particular rectangular block. Can we say that in a particular view, we can get only two views. So in this particular case, we are getting only width and height. If I want to see the thickness, then what do you do? Because already I told you that we have just projected onto this vertical plane. Now I told you that we have another plane. That particular plane is known as a horizontal plane, which is perpendicular to vertical plane. Now, if I want to view this dimension thickness, I need to view the object from the above. So what I do now is, I will consider this is, I am going to observe this particular object from the above. Okay, now once I view from the object above, again you can see, I am just going to draw the projectors like this. Can you see these are projectors now? So again these projectors are perpendicular to HP. Since they are perpendicular to HP, that is the reason we consider them as orthographic projection. Okay, now tell me how do you get the point now? Once I look from the top, we have this A. So I can see this A. So I will write this A here. And remember, whatever the view we are going to get which is projected on horizontal plane, since I am viewing from the top, that is above, we consider this as top view. So I can say above or I can say top. Whereas this is I am looking from the front. So I can, in general I can say that whatever we project onto this horizontal plane, the resulting view is known as top view or plan of that particular object. Similarly, whatever we project onto the vertical plane, the resulting figure, what we are going to get is known as front view or elevation of this particular object. Because generally, this plan and elevation are very more popular terms whenever the civil engineers will use this. I think you would have heard that now. See, whenever you want to construct a house, generally we are going to see the plan. So plan is nothing but top. That is the top of the particular object or a particular house. Okay. Now I told you this is A. Similarly, if you look from the top, I can say this is B. And this point is, which point I can say? I can say this point F. So I can say this is point F. Similarly, I can see point E. Now we can see that in the top view also I have shown small letters, but these small letters without any primes, without any dashes. So that is the convention. So whenever we have this dashes means it should correspond to front view of the object. Whenever I don't show any dashes, simply say A, B, C, D small letters, then we consider that as top view of the particular object. Okay, now tell me, I have written only A, B, C, D. Well, anyway, if you look from the front, I can see B. Exactly below this B, we have this C. So, what about C here? Can you see this point C now? If I look from the top, I can see B, but I cannot see C. Now, since I cannot see this particular point C, how do you represent in your top view? It should be shown in brackets. Okay. Similarly, I can see this point F, but I cannot see this point G. So, I will put this G in brackets. Similarly, I told you that we can see A, but I cannot see this D. So, I can put this D in brackets. Finally, I can see this E point, but I cannot see this H. So, H should be here. H should be brackets. So, we can see that this particular line, even though it is a simple line, I have shown it as A, B, C, D. Since I have shown 4 points, you should understand that this should correspond to a plane. See, if it is a line, I will represent only as 2 end points A and B. Since I have shown 2 more points, you should understand that this particular line should correspond to a plane. So, which is that plane here? A, B, C. This is that particular plane. Similarly, behind that, I told you that we have E, F, G, H. So, you can see E, F, G, H. So, this is also seen as a line. Seen as a line means what? It is actually a plane. Similarly, you can see this. I said it is E, A, H, D. So, I can see E, A, but whereas H is in brackets, again this line is also shown as a plane. So, we have one plane, second plane, third plane, fourth plane. Similarly, we have 2 more planes on top and bottom. So, that becomes what? Always remember, this particular object has been formed by means of different planes. So, how many number of planes you have here? As you can see, it has got 6 planes. So, these 6 planes which are joined together will result in this particular figure. Okay, anyway, now tell me, if you look from the top, what are the dimensions I can see now? As you can see, I can see this G I can see. So, I will represent this as G. Then, what about this? I can see this yes. Yes. Now, we can see that in the top view, I can see only thickness and width. Whereas, in the front view, I see only height and width. But in combination, I can visualize a particular object. So, this is the fundamental concept of how to draw or how to show the projections of a particular object on these planes. Since again I am stressing, if you see all these projectors, just see what are the projectors? One projector, second, third, fourth. So, all the projectors are parallel to one another. Not only they are parallel, they are perpendicular to this particular vertical plane. That is the reason we consider this type of projection as orthographic projection. Similarly, if I just concentrate on the horizontal plane, you see this. This is one projector which is coming from here to here, here to here, here to here, here to here. So that is this particular line. This is also a projector. So again, these projectors are perpendicular to one another, but they are made parallel to one another, but perpendicular to the set planes. Always we will not show like this. I need to show this on a horizontal plane, or I need to show this on a drawing sheet. So what is a drawing sheet? Drawing sheet is a 2-dimensional figure, but whereas whatever the diagram I have shown here, it is a 3D figure. So now if I want to make this as I need to make this as a 2D figure. How do you make a 2D figure? Because anyway, as you can see here, your VP and HP, they are perpendicular to one another. Now I want to make them on a flat surface. So how do you make them on a flat surface? For that I need to rotate one of the planes. So generally what we do here is we are going to rotate this HP. Is it okay? And not only that, if I look from the front, HP will be seen as coinciding with this particular line. HP will coincide with this particular line. Similarly, if I look from the top, vertical plane also will be coinciding with this line. That is, if I see from the top, vertical plane is seen as a line, and if I look from the front, HP is seen as a line. Generally, this particular intersection of this HP and VP, where we are going to get both HP and VP, which is seen as a line, and that line is known as a reference line, and that reference line is generally given or it is indicated as XY. That is XY line. So if I say XY line is the reference line, which is nothing but intersection of HP and VP. Now when you told that I need to rotate this. So once I rotate this, what do you have? We have the central line. So what is this line? I will just show this line. So what is this line now? I said XY. So what is XY? I can say XY is the intersection of HP and VP. Now I need to show this, whatever I have, you can even look into the front now. So this is above XY line. So generally this above XY line, this particular distance which is above this particular plane, now you can just say this distance, that is the object which is above this particular plane, that is which is this plane, horizontal plane. So as you can see, this particular object is not resting on HP, it is above HP. Let us say it is above HP by a distance equal to, let us say, some d distance. So I will say this as d distance. Okay. Similarly, this particular, let us say h distance. Okay, let us say I will say h here, h distance. Then this particular object is in front of this particular plane now. So how much it is in front, I can just see this. So this particular distance, this is what this particular object is in front of vertical plane. So that particular distance is, let us say, given as some d distance. Is it okay? Now, if I want to show this particular view which is above XY line, I need to show this rectangle. So where do we show this rectangle? This rectangle should be at a distance equal to h above this particular XY line. So what I do then? I will just consider this. I'm just going to write on this so that what are the points here? I written A, B, C, D. Same thing I will write there. That is, I will get this as A dash, B dash, C dash, D dash. And behind this particular rectangle, we have E dash, F dash, G dash, H dash. And this distance, how much? This particular rectangle is above HP by what distance? By H distance. So I can say this distance is H. Okay, and what is this distance? This distance is nothing but width of the object. So what is the width of the object? I have taken this as P. So I will show this as P then. And what is this distance? This is nothing but height of the object. So height of this particular rectangular block I have taken as Q. So this is my front view. Because why it is front view? Because whatever you project onto this vertical plane is known as front view. So I will call simply this as front view then. Or simply front view. This is the front view. Okay, now what about the top view? Now as you can see, we have this line. This is the perpendicular line now. Once I rotate this, what will happen to these lines? What will happen to these lines? Let us concentrate on this line now. So this line and this line. Now this line and this line, now they are perpendicular. Now once I rotate this by 90 degrees, this line will be in line with this particular line. Or what I need to do is, I need to simply draw a line like this. Okay. Then I told you that this particular object is how much it is in front of VP. It is in front of VP by distance equal to D. So I will take this distance as some D distance. Then I will complete this figure. So whatever we have here, I can just replicate that. That's all. Okay. Once I replicate, then again I can show these namings here. That is AB, CD, P only, and what about this distance? This is nothing but your S distance. Okay. Now, whatever we got which is projected onto the horizontal plane is known as top view. So this particular view is considered as top view. Top view. So now as you can see that finally this particular three-dimensional figure has been shown in unison with front view and top view, such that this is my front view, this is my top view. Now you need to tell me what is these lines now. What are these lines? So these lines are nothing but this line and this line. See, this line corresponds to this line, and this line should correspond to this line. So what are these lines? They are projectors. That is the reason in the final figure I can say this line, this line, this line and this line, they are all nothing but projectors. And you can observe one more thing. These projectors are perpendicular to XY line. What is XY line? It is the intersection of HP and VP. But say that these projectors are, since they are perpendicular to XY line, we consider this projection as orthographic projection. So as you can see, I have just done this only for the illustration. You need to actually do this in your drawing sheets. You are going to do only this orthographic projection, but the only thing is you need to understand the concepts. Okay? And if you understand the concepts properly, then things will be more easier. I think we will stop now. In the next class, we will continue with further analysis of orthographic projection.